This is first experiment, that is current series feedback amplifier, right? This is the circuit of current series feedback amplifier. For this experiment, we need signal generator, power supply and CR. Last time also you studied, you already performed the experiment. What is that? We are using this power supply as a VCC. To connect the input to the circuitry, we are using signal generator. The 20 millivolt signal you have to adjust on signal generator, and that signal you have to connect here as an input to the amplifier. Here you are connecting the VCC, that is from the power supply, and this terminal you are connecting to the CRO as an output terminal. So in the circuit, these 4 connections we are using. Once again, this is for VCC, this is for input signal, this is for output signal, and as you know, this terminal we are using common for VCC, input as well as output, because we know that in the circuitry VCC remains ground remains constant, right? This common terminal we are connecting to all the terminals, and with respect to that we are measuring input as well as output. Now this connection, what is the use of this connection? This connection we are using to connect and disconnect the bypass capacitor called as CE. When this is connected, it acts as without feedback. When this is disconnected, it acts as with feedback, because this CE decides whether feedback is there in the circuit or not. Now in this circuit, what is there? If you check these two components, they are specifically designed for the amplifier circuit. What is there? Now carefully see. These two resistors are acting as voltage divider biasing. This is acting as a collector resistor, sometimes it is called as load. This is acting as emitter resistor, which connects the feedback signal to the amplifier. This is input coupling capacitor, which blocks the DC if it is present in the input signal. This capacitor is called as coupling capacitor. This blocks the DC which is coming from the power supply. Most important, what is the function of this component? This is called as transistor, 3-terminal transistor, where collector, base and emitter. This is the heart of my amplifier. Actual amplification who is doing in the circuitry? If you ask the question, you will get the answer. Transistor is amplifying the signal, right? And this is the bypass capacitor, which is the main component to decide whether feedback is there or not. Once again I repeat, when this is connected, that is with the C, circuit will act as without feedback. When this C is disconnected, circuit will act as with feedback. So in this experiment, we have to repeat this experiment twice. Once, either you remove this and take the reading. Second, you connect and then take the reading. So you have to get the readings twice. Once for C is connected and once for C is not connected. Take care that in this experiment, whatever input you are connecting from the signal generator to the circuit, that signal magnitude should be 20 millivolt constant for all the readings. You will not change the voltage for any one reading, whether C is connected or not connected. This 20 millivolt signal will remain constant. What you have to change? You have to change only the input frequency. That will start either from 20 Hz or 50 Hz. So whatever frequency change is there in the signal generator, that frequency you have to vary. You start from 50 Hz for example, and you reach up to 1.5 megahertz in a steps. Right? Simple steps. What are the steps? First 50 Hz, then go for 100 Hz, then 200 Hz, 500 Hz, 1K, 2K and so on up to which value? 1.5 megahertz. For each input frequency, you note down the corresponding output voltage, that is on the CR. And then you calculate the gain of the signal, gain of the amplifier circuitry, convert that gain into dB, convert your input frequency into log F, and then plot the graph. On x-axis log F, and on the y-axis you take gain in or you can take a normal gain. Both will do. Either you can take gain in dB or you can take gain as a normal. So like that you have to repeat the experiment. So don't cut it, now let it be. Now first you take one probe and connect to the signal generator. Right side. Correct. Take one more probe and connect here to the channel 1. Right? Now, last time also I told you, before connecting signal to the circuitry, directly connect signal to the CRO and get it confirmed your signal generator is working properly, your CRO is working properly, as well as your probes are also working properly. Now connect both terminals to each other without connecting to the circuit. Connect. Red, black, that care you will take. Right? Now carefully see here. Take precaution that these two terminals are not shorted. Now everything is connected but still signal is not there. Last time I also told you, after connecting also if signal is not there, what care you have to take. So what happened here? Yes, the output of signal generator is not turned on. Make it turn on. Yes, very good. Right? So keep in mind, after connecting also if signal is not there on the screen, you have to take care that. Check the connection of probe with output terminal. Now the button which you pressed, that will glow showing the blue light. It indicates that not only your signal generator is on, but simultaneously the output terminal is also turned on. Before connecting anything, I repeat, before connecting anything to the circuitry, for every experiment you will repeat this thing. What? Signal generator output to the CRO. What you will come to know after doing this? You will come to know that signal generator is proper, CRO is proper, as well as the wires which is called as the probe, that wires are also proper. So it will be easy. Once if you connect this and if you are not getting, you will come to know that there is a problem in the circuit itself. So for that, this is very important. Now make the changes on the front panel of the signal generator screen. Now if you check what is the amplitude of the signal, check here. What is the amplitude here? 10 millivolt. That you have to change to which value? 20 millivolt. So now where is blinker? On frequency. First change that blinker to amplitude. So press F2. Okay? Yes. After pressing F2, the blinker will change to amplitude. Now press 20. And correspondingly, where millivolt per millivolt peak to peak is written, that switch you have to press, that is F1. Press F1. Now carefully see. The value of the output signal is 20 millivolt. Whatever may be the frequency, that is next part. So I have set the output 20 millivolt peak to peak. Once if you keep the signal 20 millivolt peak to peak, here you will try to observe a straight line. The reason is that whatever volts per division switch, that switch position is not proper. Here it is showing 5. So to get the signal on the screen, you change this to 20 millivolt. Carefully see here. Now I am keeping this switch on 20 millivolt, and then here if you check, or I will keep it on 10. Now see here. Yes. Now carefully check. What is the switch position here? 10. What is the distance here? Vertical distance? 2. This 2 into 10, what is the value? 20 millivolt. Means whatever value I set on the signal generator, that value I am getting on the screen. It indicates that now everything is proper and now you are ready to connect the input signal to the circuit. Before that, take two more wires, one red and black. Take the probe. Okay. Now use these patch cords and connect the signal from power supply to circuit as a VCC. Take these wires. Connect red to red, black to black. Right. Before connecting this signal to the circuitry, adjust 9 volt on the power supply. Adjust 9 volt. Increase that. Course. Make 9 volt. Okay, let it be. No need to adjust exactly 9. If it is 9.1, 9.2, it's okay. To adjust the value exactly with course, you have to use fine. So it will adjust to 9. So you have to take care that before connecting signal to the circuit diagram, you set the value, right? Then switch it off and then connect the signal to the circuit. How to connect? Red wire you connect here. This is your VCC, right? This black wire you connect here. So these two connections are showing power supply is connected to the circuit. Now disconnect these wires. Right? Connect these two. Input signal from signal generator to the circuit. So red wire here. Wait. If you connect the signal using this, you will be unable to connect the third signal to the CRO. So better way, you take one more black wire. Yes, this you connect here, right? And this black wire you connect to this side, right? Now one more connection is remaining, that is the output of circuit you have to connect to the CRO. So these are the two wires. Connect red wire to the circuit first. Yes, and then use this third terminal, black wire, to the common terminal. Right? These are the connection. Once again I repeat, these two shows VCC, these two shows input signal, and this two connection shows output terminal. Now your circuit is ready with connection. Take care that while connecting, most of the time you will keep the power supply off, just to avoid the damage to the circuitry. I know now the voltage of this power supply is adjusted or set for 9. So now you switch it on. Yes. If you check, after connecting the supply, input signal, now you are getting the output on the CRO. Previously, when you measured the voltage with the input signal generator, what was the reading at that time? 20 millivolt. But now you check the signal, you will find out that the amplitude is increased. Take care that at that time I have not connected this CE. Means when this is not connected, my first table is amplifier with feedback, because my C is removed, it is not connected. So the first observation table which I am completing here, that observation table is for with feedback. So with feedback, what output I am getting here on the screen, now you check. Now carefully see, this volts per division is on 20. So what is my multiplier value? 20 millivolt. This 20 means it is millivolt. Carefully remember this. 20 millivolt. Now, if I check using this Y position, how many lines are there for my output signal? Carefully check. 1, 2, 3. And it is not exactly 4. I can say it is 3.8. You have to take the approximate value. So it is 3.8. So using calculator, you just find out 3.8 into 20 millivolt. Anyone of you do this? Take the calculator fast immediately. Person who is having calculator, take it out. 3.8 into 20 millivolt you have to take, not only 20. Many times one person may make the mistake. So when you are doing the calculations, simultaneously you have to do. So one more is expected. Next time you take here. So 20 millivolt into 3.8, right? Press engineer. Okay, tick. So it is giving the answer. How much? 76 millivolt. What is the value? 76 millivolt. What was my input? 20 millivolt. What output I am getting now? 78 millivolt. My input is increased from 20 millivolt to 76 millivolt. This is the amplification action. At that time, the frequency which I set, what is the value of that frequency? It is 100 Hertz. You can start the reading from 50 Hertz. This is one example I have shown. Now you will get that initially the output voltage will start increasing. In between it may remain constant and again it will start decreasing. So if you change the frequency from 50 Hertz to 1.5 megahertz, you will get the wave shape initial rise, steady and then again fall. So that graph you have to plot on the graph paper, which will give you what is the bandwidth of your amplifier. So just as an example, I have shown the value for 100 Hertz. In between reading, I will show you. Now you make it 5 kilohertz. Now first take the blinker on frequency. So press F1 first. Correct. Now make it 5 kilohertz. Press 5 and kilohertz. That is 5 kilohertz. Right? Now carefully see here. If I adjust this, now here I am getting the same value. Right? If you increase the value, now make it 50 kilohertz. Press 50 and then kilohertz. 50, 50 kilohertz. F2. See here. Again, the gain remains constant. Now make it 1 megahertz. 1 megahertz, where first one. Yes. Now see here. It is slightly decreased. Now it is 1 to 3.2. If you make it 1 megahertz, you will get the signal magnitude is slightly decreased. So initially some rise or chances are there you may get constant. In between it will remain constant and again it will show slightly less than the previous one. So for all the input frequencies in steps, you have to repeat the readings and you have to plot the graph. Is it clear? So when you are keeping this open, once again I repeat, it is acting as weak feedback. So I told you, if you connect this signal here, it is acting as a without feedback. And I told you, when feedback is not there, the gain of the amplifier will increase. Now very simple, just make it 5 kilohertz first. Right? Now here you check. Now, if I connect this, the gain will slightly increase. Now, carefully see here. There may be some disconnection. Just carefully you have to connect the signal. Here, using level, you have to adjust it. Right? Now, see here. I will connect here. I think there is no way, so I will connect here. No problem. See here, this is common. Now see here, gain is increased. Somewhere there is a disconnection. See here now. Previously we used to get 76 millivolts somewhere. Now see here. Where is my pointer now? 0.1. This pointer is on 0.1. Now see here. 1, 2, 3. You keep approximately 3. 3 into 0.1. What is the value? 0.3. It gives you 300 millivolts. When feedback is not there because I have connected now C. When C is connected, it is acting as a without feedback. Without feedback, gain should be more than with feedback. If I remove, just check here, the gain is decreased. See here, gain is decreased. Now what is the value? It is 50 into 1.4. 1.4 into 50. Whenever you are taking the reading, take the vertical height and then multiply to the respective pointer. You will get. Please note that whenever you are taking multiplier, don't take only 5, 10, 20 or 50. It is in millivolt. So that care if you take, you will get the reading. Right? Now only one reading I will show. All other readings you repeat. Make it 50 Hertz. 50 and Hertz.
F3.
This is 50 Hertz. When 50 Hertz is there, signal magnitude is very small in terms of frequency. You change this. It will not be stable because frequency is very less. So don't try to make it stable. If this is the value display, it's okay. Now check here once again. This is 1.4 into 50. Whatever readings you are getting here, just note down in your respective observation table. One person will change that. Second person will measure. Third person will write. Fourth person will calculate. And like that simultaneously you complete the table.